Hello, I am Mahid Atif Hussain, a student from the course cse449. My ID is 211011170, and now I will be starting the Unix shell tutorial. Okay, so first of all, let's look at our current directory by using this command pwd. Okay, so we are currently here. Now let us look at ls, these are the current folders. I'm using Ctrl plus L to clear my terminal, or clear will also work. Okay, so we can use the -f option, which tells ls to classify the output by adding a marker to the file. Okay, so let's do this. Okay, so we can see that shell lesson is a folder here. Okay, now the clearing part is done. You can see the help. This is all the information here. Okay, with this, clear this section. Okay, now. Okay, let's use an unsupported command. Ls j. You see that it's not working. Okay, now let us look at -l. Okay, use two options at a time. What is the command ls to use with the ls option? Okay, ls that l. Okay, so we can see that there are total four. What does this four mean? Including phase, okay. Okay, long list formatting. Okay, shows only the file directory name and additional information. Okay, so file size, time of its last modification, makes a human readable. Okay, let's make it human readable. H. Okay, so nice. Okay, so this is using 4 kilobytes data. Okay, by default, ls data total. Command #r lists the content directory in a reverse order. Okay, let's go to this. Okay, exploring other trees. Okay, we can put that later. Okay, look at here. Okay, lsf. Okay, let's do this. Okay, yeah, we can see everything now. We can do this as well. Yeah, this is working as well. Okay, so using the dot after the -f, we can see which are the files and which are the folders here. Okay, now let us go to desktop. Okay, now let us go to our roll number. Okay, now we're in the shell right now. Now let's go to the exercise. Okay, yeah, we can see that there are files and folders here. Let us look at this. Okay, so we can see the numbers is a file and proteins is a folder. Writing is also a folder. Okay. Okay, we're going here. Okay, fine. Special directory doesn't usually show up. The -a. Okay. F and -a to look at the special //1. Okay. Uh, Now we need to go to the folder and okay, that's about it, I guess. Okay, so looking at the absolute path. So the following command should Amanda use to navigate to her home directory, which is /user/Amanda. Okay. We can use file number one. Yeah. ed tilde. Yep. We can use this to go to our home. Yep. Yep. This is working right now. reading comprehension, reverse order, general syntax of a shell command. Okay. Nell's pipeline problem is okay. Let us go to the not specific one. Okay. Command is a lot to type, but can let the shell do most of the work too, which is called the tab completion if she types. No, yeah, I'm using the tab completion right now. Tab completion. Okay, to see all the she can press tab twice. Okay. Uh okay. We can use that PDL. Okay, not see all those files. She can press tab twice more, and then you can use this. This is not working for some reason. Okay, not a big deal. Just keep moving on to the next lesson. Okay, working with files and directories. Okay. Okay. Step one, see where we are and what we already have. Look at this. WT is our current directory. We can go to exercise, writing, CD. Okay. Now look at this. Yeah, we have haiku and little woman. Create a directory. Let's create a new directory called thesis using the mkdir command. Okay, let's make that mkdir thesis. Okay, so we have the thesis. ls-f or ls-f-f. Okay, we can see that haiku and little women are text and thesis is a folder. Yes. Okay. Icon F thesis. Okay, there is nothing inside of it. Okay. mkdir is not limited to creating single file down. We allows mkdir to create a directory with nested subdirectories in a single operation. Okay. So we can make multiple. Okay. Let's make this mkd. Okay, no, let's go inside thesis. Okay, now mkdir -p / project data / data and dot project results. Okay, that did the job. Let's look at here. Okay, we have the project and we have the thesis. Okay, everything is looking great now. We're doing the same thing. Create a directory that is file explorer, good names for files and directories. Okay, let's create text. Let's go to the thesis and a draft txt. Be sure create a text file, which editor? Edit Mac. Okay. Let's do this and we can write publish British. More. It's share and try. Okay, now let's just save this. Yes. Okay. We can see that we have a draft.txt file now. Okay, let's touch creating files a different way. Okay, touch my file.txt. Okay, we can make a new file now. Okay, we can now delete it. My file. Done. cd moving files and directories. Okay, running the shell command, writing directory. Okay, we just copy and paste this command here. Okay, no such file or directory. Okay, so this will basically rename this file, I think. Okay. Okay. Let's do this now. MV thesis. Yeah. MV thesis slash .txt thesis quotes.txt. Let's do this. Thesis. Yeah, now it's quotes. Okay. One must be careful specifying the target name or over here. So delete to loss and additional. Okay, fine. Okay. But then we can confirm the course that takes is no longer present in our thesis directory. Okay. Let's do this. Thesis slash which commands? Oh, we can actually move this. This is empty. Okay, let's do this. Empty. This is slash quotes txt. Yeah, now we are moving this. Okay. Let's go to thesis. Now it's empty. Now let's thesis quotes.txt. Yeah, we cannot access it because it doesn't exist now. Okay. Okay, now running realized that she put the files sucrose.dat and maltose.dat in a wrong folder. File should have been placed in raw folder. Analyze. Okay, moving fast to new folder. Okay. Where is this now? Is this a protein? No. Okay, so file should have been okay. Go in the blanks to move these files to the raw file. Once you forgot to put in. Okay, analyze this. Okay, it's not here. Animal counts protein. Resident creatures. Gosh. Let's go to the okay, no problem. Okay, so analyze to the that yeah raw folder. Jamie realized that she of sucrose.dat and maltose.dat into the wrong folder. File should have been placed in the raw. Okay, let me think about it. It's here mv dot not that and maltose dot that to it here most probably records to the previous folder. Copying files and directories. Okay, the cp command, much like the mv command, except it copies a file. Okay. Okay, fine. Let's just copy quotes txt thesis quotations txt. Right here we have quotations.txt. Okay, let me just get this. Okay, great. Ls quotes.txt. Okay, now let's just ls quotes.txt and thesis slash quotation.txt. Okay, now we can ls. Okay, we can copy a directory and all of its contents using the recursive option cp at r thesis underscore backup. We have thesis or backup. Great. Naming the files. Suppose that you created a plain text current directory to contain a list of the statistical tests you will need to do. Analyze your data and name it statistical.txt of creating and saving this file. You realize you misplaced the file. You now need to correct a mistake. Which of the following commands would you use? Create a plain text file in a current directory to contain a list of the statistical tests. Okay, the data name is statistics.txt. Okay, we can actually use the move command. Use the move command. Yeah. Yeah, we can probably use mv statistics.txt statistics dot statistics.txt and statistics.txt. Yep, that should work. Okay, now moving on. Moving and copying. How much do we have left? Okay. WD uses Jamie data. Teams.data. Okay, so now let us look at this. Plus codes does not exist. RMI, this is the backup. I should this. Okay. Okay, that will make us this prompt. Okay. Okay, let's just parse this. RM pieces. Okay, now we deleted it. CD creatures. Basilic, Minotaur, and Unicorn. Okay. Backup. That's F. Yeah, the backup has been created. You can just copy. Oh no, this should be one step above. Backup. Backup to obey. Okay. Now we have the backup. Okay, now let's uh just copy features. Minotaur features slash unicorns. The backup. Okay. CD backup. Okay. It's here now. Okay, we need to move the. Okay, we need to move other. Let's just features slash. Which one are we missing? Basilic. Okay, so this is none. We have copied it. The creatures. Backup. Yeah, all of them are here. Okay, wildcard to accessing multiple files at once. Okay, which one's the protein directory? Let's look at protein. Okay, so let's look at this. Run the proteins directory. Which ls command will produce this output? Ethane and methane. Butane, methane, and ethane and methane, right? Pentane also has a P. Okay. Let us look at this one. Proteins. ls all P. ane dot P. db. Okay, I got ethane, methane, octane, and pentane. Okay. The question mark probably. All P. And then question marks. ane dot db. Okay, we're getting the ethane and methane one, so this is probably the correct one. SAM has directory containing calibration data, datasets, and descriptions of data. CP. Okay. Team is working on a project and Analyze fructose runs. Use a full structure of this. Okay, so now let us look at the pipes and filters one. Okay, so this the proteins one, right? Proteins one, yeah. Okay, ls protein. Okay, we have this dd to the proteins. Oh, sorry. Okay, now let us do this work on butane. Butanes.pvd 2015 150 1158. Okay, let's do this. Word count all.pvd. .pvd. Okay, we have this. We have also the total one in here. Let me just set as this. Word count l all.pdb. The l will give us what? Uh, okay, so it will only give us the lines. Okay, let's do it with m. Thems can also use only number of characters. Okay, let's do this the number of characters and the top words. Okay, really straightforward. Okay, so we have an okay. We need to close from this. Okay, capture output from the command cl all.db capturing commands into what's this text. Okay, let's just do this cat line. Okay, so all the text has been put into lengths.txt. Okay, it's fine now. Okay, let's just do sort and length. Okay, so it's sorting in the numeric order. Fine. Sort and lengths dot text it into file called sorted lengths.txt. Now we're going to do head. Head will give us the first few lines. Okay. Sorted. Okay, so it's only giving us the first line on the head. Okay. And okay, pretty straightforward, I guess. Okay, the one. Okay. Sort and lengths. Put it into dot text. Okay, let's see what happens. Okay, so cat lengths. Okay, we have the lengths one and it is actually not really sorted here. Redirecting the output of a command that operates on a file to the same file. Okay, that's a bad idea. We're going to use echo command check. Okay, fine. Echo. Do we have a hello? No, we don't really have a hello. Echo hello into test file 01.text. Text test file. Okay, we have hello in here. Test file 02.text. Yeah, so let's just clear this. Just file 02. Okay, so that has hello. Okay, now let's just try this again. Okay, so this is appending, the double arrow is appending to the file. Pretty easy, I guess. Animals.b. Let's just go to the animals. Add numeric three animals dot csv into animals subset dot csv. Okay, so we have the first three lines from animals.csv there. Here to tail n to animals.csv and put it into animals subset dot csv. Subset. Okay, so all of this is the first three lines and the last two lines are now in the animals subset.csv file. Output to another command. We can do this sort and do we have links here? No, we don't really have links here. Let's go to here. Wait, which is not here. We need oh, ribbon is this? Okay, so it's the exercise data animals count numbers.txt. 2 intermediate files, length.txt and sorted.txt. Store some outputs is confusing. We have a numbers.txt. Okay, that's in the proteins, right? Yeah, that's the proteins one. Okay, now let's just look at this. Lengths.txt. We're going to pipe it into the head. And well, let's just see. We have 9methane.ppd. Okay, so this is what we want. We don't really need the sorted link. Okay, we don't need the sorted one now. Okay, now let's just do the word count L using all.pdb ones. Literally all of them. All.pdb. Pipe it into sort, then use the N one. And now we have it in sorted form without using the intermediary file. Let us do the sort N and then put it into the head numeric 1. We will get 9methane. Done. Now let's just go to the animals CSV. Okay, now we have cat animals dot csv the head. The first 5 lines will be chosen, and then we have to put it into tail, where the first 3 lines will be chosen. Then we will be put into the sort, where R probably refers to the reverse order. Yep, into final dot t. Okay, didn't find the tails into tail. At final, yeah, we have those now. Okay, for this, is this the right solution? This is the right solution. Okay, now moving forward, we need cut, then this is our delimiter, then we have f2 animals dot csv. Okay, what? Okay, okay, deer, rabbit, raccoon, rabbit, deer, fox, rabbit, deer. Okay, please remove sections. Okay, unique command filters, adjacent meshing. Okay, we just need to do this. Okay, so let us delimiter is squish f2 animals csv. Now we, okay, the f option specify you want to extract a second field. Okay, we want the second field, and then we can just sort it. We're using sort because it will sort it alphabetically, and the ones with the similar starting alphabet will be sorted together, and then we can just use the unique command to just remove the duplicates. So I'm using cat again. I use cat. Okay, bear, deer, fox, rabbit, raccoon. Okay, this is working right now. Okay, let's just get animals dot sb. Okay, fine. One has a C option. The unique command has a C option, which gives a count of number of lines a line occurs in its input. So we can do animals.csv, and then we can pipe it to unique, and we can see. Okay, now we can just use this sort. Okay, wait, pipe it into sort. Do we actually need to pipe it into sort? We would produce a table that shows the total number of each. Okay, let's just do this. We need to use cut now. Okay, so let's use cut, and then the d, then delimiter. Okay, we want the second field, animals dot csv, and then we need to put it into the sort, and we need to put it into unique. Obviously, the okay, wait, we use that one, the C command. C, it gives us a count. Then we just, yeah, that should actually be the solution. Unique C. Yep, one bear, two deer, one fox, three rabbits, and one raccoon. That's our answer. Let's pipe on checking files. Okay, we need to go to a different file now. Okay, not here. Okay, word count L using all the dot text file. Okay, we have a lot of files now. Dot text files, and then you can just put into the sort and then head file. Okay, so we are using the word count and L to give us the list. Using all the text files, sorting it according to number, and then putting it in the head using the first 5 lines. Okay, and this now looks, one of the file is 60 lines shorter than the other. 60 lines shorter than others. When she goes back and checks it, she sees that she did a essay at 8 a.m. on a Monday morning, probably using the machine on the weekend. She forgot to reset it before renewing the sample. Checks to see if any files have too much data. Okay, and we have to use the tail and the 5 tail. Okay, so we actually have, okay, the last 5 lines actually have, last 4 lines actually have 300 ones. Okay, those numbers look good, but what's that C doing there? LSO C dot. We have a file with a Z in it. She checks the log on her laptop. There is no depth record of either of the samples and it's too late to get the information. She must exclude these 2 files from analysis. With them using ARIA, but there are actually some analysis she might, so she'll have to be careful later on to select files using the wildcard expression. Delete your process data and only keep your raw files, and process script save storage the raw file. Dot data file in the text. The following would remove all the process data and only process data files. Probably rm alt text file with this. Yeah, that should do the trick. Okay, sure. Okay, so now we will look at using loops for the next bit. Let us look inside Basilic. Okay, so this is the genomic sequence. Okay, the very big line. Classification. The first line is about. Second line is about classification. This first name is about common name, and then this is updated, and then the genome sequences. Okay. Okay, now we will look at the first 5 lines of these files. We can actually use this, I think. Yeah, this is data, but we actually need to do this in a much more efficient way. For that, we are going to use loops. So just write something like file in basilisk minotaur and then unicorn. Wait, do we need to do this? Okay, file in basilisk data to, how do we write this? Okay, so we actually need to do the loop now. In Basilisk, and then Minotaur and Unicorn. Need to do this. Signify that this is one part of the command, and this. Then we need to do head and two, and then the X. X basically signifies each line in our uh, whole data set, which includes Basilisk, Minotaur, and Unicorn. Okay, now we have to pipe that in tail, and then we need the first one line. This isn't done yet. We need to do one more line, which is the done, and then we should have the yeah. So we have all the information here, classification of each of the three files, and taking in the first two lines from head, and then the first line from the tail. Okay, now okay, so here basically the color of our arrow changes when we need to write more command to complete the whole command. So go to the PBD ones. Here. Themes, yep. Now let's do a loop here for data file in all.pdb to now we have to do ls all.pdb and then done. Okay, so we are actually getting a loop here. Now what is out of the following code? Why do you leave it different output? Data file. This again. Data file in all pdb to ls data file. ls data file. Yeah. Okay, so these are actually giving us two different outputs, even though they are basically the same. Okay, so in the second loop, we are actually only printing out the file data, but in the first loop, we were actually printing all of the .pvd files. That is why the two loops are actually different, limiting sets of files. Okay, routines. Okay, we just need the files that start with C. Okay, so for data file in C to ls. Okay, so this is actually file name. Sorry, file name in C. ls file name. Done. Okay, we're getting the cubane.ppd. Oh wait, we actually need to do all of them. File name. Okay. Only cubane.ppd is okay. How would you output different for using different? Okay, we can do this. .c. This will output cubane and bane as well with octane file. Okay. So the cubane.ppd and the octane.ppd both will be outputted here. saving to a file in a loop part 1. Okay, but we have alkane here. We don't seem to have alkane here. Okay, so for alkanes in all.pdb, to echo alkane, okay, and then cat alkanes into, okay, into alkanes. Do we have alkanes? Yep, alkanes, pvd, done. Okay, so we are printing the alkanes and they're putting the names of the alkanes in alkanes.pvd. So let us get alkanes.pvd. Okay, so we actually have the data now. Data of the alkanes is now in alkanes.pvd. Data file in .pvd. Okay, now we have to loop through all the data. To add data file into all.pdb. So we are putting all the data of all of the PDBs into a single file. Yeah. Cat all. Yeah. So all of them are now here. Okay. Next. Okay, so now we will be moving on to the shell scripting part. Okay, so let's do this. We're already in the proteins now. Nano sh. Nano is the text editor and mail.sh is the name of a file that we're about to create now. Type in head n 15 octane dot pdb dot pdb and then pipe it into tail. Well, the first line from the first 5 lines from the tail will be printed. Okay, now let's just save this. Now we need to bash this middle dot sh. Tails not okay. We need to nano this. Tails does not exist, but tail does exist. Okay, now let's do this. Yeah, we can see the data from the octane dot pvd. Text is what edit the middle .sh file again. Then now, okay, head nano 15, and then we have to use the $sign, and that $1 basically means the argument that the first argument that we're passing to the middle.sh file. Okay, now tail and 5. Okay, now let's just save this. Now middle.sh octane.pvd. Yeah, so here octane.pvd is the first argument to middle.sh file on a different file like this. Okay, we can middle.sh on contain PBD. Yep, this is also working. Now we can also use the, okay, let's do that. Non-analytic n, and then we have to use the, okay. Okay, the second argument, and then this is our third argument. Let's just save this. Now I'll just clear a window. Bash middle.sh and pentane, and then 20 is the head. First 20 lines from pentane, and then the first 5 lines from the tail. Okay, so we are getting the output. Okay. Comments. Okay, let's add some comments. Select file. Usage. Middle.sh. File name. Number of lines. Okay. Now we're just saving this here. Okay. Now for the next part. Now to make a new file, I guess. Okay. Sorted.sh. And sorted.sh. We have to use work count. This here at sign is used. Where is that symbol? At $at. Okay, so the $at basically means all the arguments will be piped into sort numerically. Say that now. Bash sorted.sh all.pdb. Well, this should work as well. Now all.pdb and then // features all.dat. Yeah, this is giving us all the information now from the creatures basilisk as well as the sorted, current directory. Yes, it's working. Yep. This unique species. Okay. Okay, I think that concludes our tutorial. So that's about it.